Hey geometers, welcome back to another video lesson with Mr. Forster. Today we'll be looking at our fourth lesson of Unit 7, going over types of parallelograms. So let's go ahead and get started. A reminder, our definition of a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. And we went over in our last lesson a few properties that they have. So things like their diagonals bisect one another, opposite sides are congruent, opposite angles are congruent. And we can have some more specific shapes that are still parallelograms but have some additional features. The first one is known as a rhombus, which has 4 congruent sides. So all 4 sides will be the same length. The next is a rectangle, which is a parallelogram with all 4 right angles, or all 4 angles congruent. So our rhombus is our equilateral parallelogram. The rectangle is our equiangular parallelogram. And then the square is both. It has 4 congruent sides and 4 right angles. So it is a regular polygon. What happens with this family of parallelograms is each of the shapes as we go down this concept map here will inherit all of the properties of the shapes above it. So the parallelogram, which had opposite sides parallel, opposite angles being congruent, consecutive angles being supplementary, and diagonals that bisect one another, all of those traits are still true of the rectangle and the rhombus, with some additional features that we'll talk about today. Another component of the rhombus is that its diagonals are perpendicular to one another. So when we look at the diagonals of our rhombus, let me grab my pen here. One of the diagonals here is BD, the other one is AC. They will be not congruent, they will be perpendicular to one another. So we have this feature of the diagonals being perpendicular. Another feature of the rhombus is that each of the diagonals bisect the opposite angles. So in this case, this angle will be congruent to this angle here. This angle will also be congruent to this angle here, and all 4 of those are congruent to each other. And then these 2 angles at the bottom are congruent to these 2 angles up top. Excuse my poor drawing skills here. So again, the 2 new features of the rhombus are that the diagonals are perpendicular and that the diagonals bisect the opposite angles. For part 8, I will do part A, and then I will have you try part B and give you some time to work on that before resuming the video. For number 8, it wants us to find the measures of the numbered angles of the rhombuses. Now it's important that we know that these are in fact rhombuses, or sometimes called rhombi for the plural. And in this case, if I want to find the measures of angles 1 and 2, I can use the fact that angle up here at N is 120, which means this entire angle down here has to be 60 degrees. And since the entire angle is 60, the fact that the diagonal will bisect the opposite angles tells me that both angles 1 and 2 are both 30 degrees. And I can use the same argument for using angle N and angle P over here. They're still consecutive angles, so they should be 60 degrees for the entire angle as well, for angle NPQ. And since angles 3 and 4 are made by the diagonal, they will also bisect that angle, which means each of them is also 30 degrees. So I want you to take a moment and see if you can figure out what the measures of angle 1, 2, 3, and 4 are in part B. Okay, I'm going to start with angle 1, and I'm going to use the fact that the diagonals are perpendicular to each other, which means that angle 1 has to be a right angle, which makes it 90 degrees. So there's angle 1. For angles 2 and 3, since angles 2 and 3 are part of the same diagonal as the 50 degrees, the diagonal is going to bisect both of these opposite angles. So that one's going to be 50, and so are angles 2 and 3. So there's how I get those. And then to get angle 4, I have a little bit more work to do. Since I have a right angle up there, I'm also going to have a right angle right here, which means this bottom triangle is a right triangle. And since this is a right triangle, and I know one of the acute angles, I know that angles 2 and 4 should be complementary. They should add up to 90 degrees. So, since this is 50, measure of angle 4 is going to be 90 minus 50, which is equal to 40 degrees. So the measure of angle 4 should be 40 degrees. Here we have the first additional feature of the rectangle, and it states that if a parallelogram is a rectangle, this happens if and only if its diagonals are congruent. This if and only if statement, that means that if I see that diagonals are congruent in a parallelogram, then it has to be a rectangle. And if I know that it's a rectangle, then its diagonals have to be congruent. The if and only if means that the theorem and converse both work. So in this case, on number 10, it says find the length of segment FD, which is one of the diagonals, in rectangle, so we know it's a rectangle, GFED, and we're told that FD is 3y plus 4, and GE, which is the other diagonal, is 6y minus 5. So what we can do is, since we know this is a rectangle, that means that its diagonals are congruent. So I can set these equal to each other and say that 3y plus 4 is equal to 6y minus 5. I can subtract 3y from both sides. That leaves me with 4 is equal to 3y minus 5. From there I can add 5 to both sides, which leaves me with 9 is equal to 3y. And then finally, to solve for y, divide by 3, and I get that 3 is equal to y. Now it wants the length of segment FD, so I need to substitute the value of y into the y for segment FD. So FD is equal to 3 times the value of y, which is 3, plus 4, which is 9, plus 4, which is a total length of 13. FD is equal to 13. All right, finally, we have this set of information given to us, and we need to determine or conclude whether or not we can determine if it is a rhombus, a rectangle, or neither. In our first diagram, we're told that the angles on either side of the diagonal are congruent. Now, interestingly, it says here that these have a different, potentially different value. However, we know that this is a parallelogram, which means if the angles are being bisected by the diagonal, since it's a parallelogram, you would start with the same value for the total angle on each, which means that all 4 of these would in fact have to be congruent, knowing that it's a parallelogram. So this is going to be our rhombus. And the reason that we know that is that the diagonal is bisecting the opposite angles. For part B, it states that AC is congruent to BD. And since we know it's a parallelogram, this only happens if I have a rectangle. And we would say this: the diagonals are congruent. And then finally, we have a parallelogram has angles of 30 degrees, 150 degrees, 30 degrees, and 150 degrees. That's good because parallelograms' opposite angles should be congruent, so this makes sense. However, there's not enough information for us to determine whether it's one of these particular types of parallelograms because we don't know anything about the diagonals. So I can't make any determinations. We would say neither here, and then we would say there's no info about their diagonals. All right, that concludes the lesson. Super short today. You do have an assignment that will be posted in Google Classroom, and it's in the textbook, so you'll need some extra scratch paper. So it is problems 3, 5, 7, 9, 11, 13, 21, 22, 25, 26, 29, 30, 31, 32, 33, and 34. And this should be section 7.4 of the textbook, again posted on today's post in Google Classroom. As always, if you have questions, comments, concerns, feel free to send me an email or wait until we have time together on Monday. Have a fantastic weekend, and I will see you Monday.